welcome to episode 8 of AI Solutions, the Pathway to Profit. Today's topic is the AI tech stack, and let's be blunt, it's a term often used to make things sound more complicated and expensive than they need to be. I've sat in meetings where a startup founder who just wants to predict customer churn gets buried under an avalanche of acronyms and vendor logos until they're convinced they need a Silicon Valley budget to even begin. It's nonsense. My goal here is simple. Cut through that noise. We're going to break down exactly what you need to get started. By the time we're done, you will have a clear, actionable roadmap, a shopping list really, of the essential tools from data storage to getting your first model working for you. So, what even is an AI tech stack? Let's ignore the jargon for a second. What I like to do is think of it like setting up a professional kitchen before a big service. You have your ingredients. That's your data. You have your knives, mixers, and pans. Those are your software libraries and tools. And you have your ovens and stovetops. That's your computing power. You wouldn't try to run a steakhouse with just a microwave, right? This is why it's so crucial. A well-chosen stack ensures you're efficient. You can scale up when you get popular, and you're not wasting money on gear you'll never use. A smart stack is a direct pathway to profit. A poorly planned one, well, that's just a recipe for a failed project. All right, let's start at the absolute foundation, the bottom of the pyramid, your data. The first big decision you face is where this data will live. Do you keep it on-premise, on servers in your own office, or do you put it in the cloud? Now, for most small to medium-sized businesses I work with, this isn't much of a debate anymore. On-premise gives you total control, which sounds great, but it also means you're the one buying, maintaining, and fixing the hardware. It's a huge upfront cost, and a headache you probably don't need. What I almost always recommend is starting with the cloud. It's flexible. You only pay for what you use, and it scales with you. You might find it's like the difference between buying a power plant versus just paying your electricity bill. Once you're in the cloud, you'll hear terms like data warehouse. Think of services like Snowflake or BigQuery as highly organized libraries for your structured data, and data lakes, which are more like vast reservoirs for everything else. Don't get bogged down by the names yet. Just remember this. Your choice here, this data foundation, will dictate the success of everything you build on top of it. Get this right, and you're on solid ground. Okay, so our data has a home. Now we need the engine room, the raw power to actually train our models. This is where you hear people debate CPUs versus GPUs, and it's simpler than it sounds. What I like to do is think of a CPU as a versatile chef's knife. It's brilliant for handling a sequence of different tasks: slice, dice, peel. A GPU, on the other hand, is a specialized food processor. It might only do one thing, like chopping, but it does thousands of pieces simultaneously. When you're training an AI model, you're doing the same simple calculation millions of times over. You need that food processor. But here's the best part. You don't have to build the kitchen. You might find it's much better to use cloud platforms like AWS, Google Cloud, or Azure. They let you essentially rent that supercomputer power by the minute, which makes powerful AI accessible without that massive upfront hardware investment. So, with our data stored and our engine ready, we need the actual toolbox. What I always recommend, and frankly what almost everyone uses, is the Python programming language. It's become the dominant language for AI simply because it's easy to read and has a massive community building amazing tools for it. Now, within that toolbox, there are 3 specific tools you'll encounter constantly. First up is a library called pandas, What I like to call it is Excel on steroids. It's the tool you'll use to load, clean, and manipulate your data. Next, you have scikit-learn. You might find this is the Swiss Army knife for most of your early projects. Great for building classic predictive models. Finally, for when you need the really big, powerful stuff, like image recognition, you have the heavy machinery, TensorFlow and PyTorch. Don't stress about the details now. Just know these are the core tools you'll need on your workbench. So we have our toolbox, but a pile of tools isn't the same as a workshop. This is where we set up our workbench. What I see as absolutely crucial is moving beyond just a successful experiment into a reliable business product. This is a concept called ML Ops, or machine learning operations. Think of it as the assembly line for your AI models. It's what solves that classic project killing problem. Well, it works on my machine. ML Ops provides the structure to ensure your model can be built, tested, and deployed reliably every single time. You might find that comprehensive platforms like Databricks, AWS SageMaker, or Google Vertex AI are designed to manage this entire lifecycle, turning your clever idea into something the business can actually depend on. Okay, but what if all this talk of toolboxes and workbenches sounds great, but you're thinking, Gavin, I don't have a team of data scientists. This segment is specifically for you. What I see as the great equalizer in this space is the rise of low-code and no-code AI platforms. You might have heard of names like DataRobot or H2O.ai. What these tools do is truly remarkable. They let you build incredibly powerful models using a graphical interface, often just by dragging and dropping elements. You bring the business knowledge and the data, and the platform does the heavy lifting of building and testing hundreds of models for you. The upside is obvious, incredible speed and accessibility. But what I always point out is the trade-off. You lose some of the fine-grained control and deep customization you get from coding. And you need to be mindful of vendor lock-in. But for many, you might find that getting a powerful, profitable model up and running in days, not months, is a trade worth making. All right, at every step on this journey, you're going to face a critical decision. Should you use a free open source tool or pay for a commercial one? What I see work well is starting with the open source world. Think of those Python libraries we mentioned. The appeal is obvious. They're free and incredibly flexible, but the hidden cost is expertise. You have to have the in-house skill to stitch them together and troubleshoot when things go wrong. Then you have the commercial route. Here, you're paying for ease of use, a polished product, and, crucially, support. There's someone to call when you're stuck. You might find, however, that it's not an either-or question. What I almost always recommend is a hybrid approach. Use that powerful open source foundation for your core work, but don't be afraid to pay for a specific commercial tool that solves a high value problem better or faster than you could on your own. It's about being pragmatic, not dogmatic. Okay, enough theory. Let's get really practical and build your first stack. So, where does your data live? What I almost always recommend for a starting point is a simple cloud storage bucket. Think something like AWS S3 or Google Cloud Storage. It's cheap, secure, and basically just a folder in the cloud. Don't overcomplicate it. Now, where do you do the actual work? You might find you don't need a powerful server just yet. What I like to see clients start with is a managed notebook, like Google Colab. It gives you free access to powerful GPUs right in your browser. And the tools? Stick with Python. For most business problems, you might find that the combination of pandas for data handling and scikit-learn for modeling is more than enough. That's your starter kit. a cloud bucket, a free notebook, and 2 libraries. This setup is all you need to start delivering value without over-engineering things from day one. We can talk about the perfect tools all day, but what I've learned is that a tech stack is just a very expensive paperweight without the right people to run it. This is the hidden cost that can sink a project. Now, you might be thinking you need to hire a whole department, but that's not always the case. What I like to see is a focus on the essential roles, even if one person wears multiple hats at the start. You need the data engineer who gets the data ready. You need the data scientist who builds the model. And you need the business analyst who makes sure you're solving the right problem in the first place. You might find, though, that the most critical person on the team is the translator, the one who connects the technical possibilities with the actual business needs. They ensure you're not just building cool tech, but building a solution that generates profit. Okay, you've built your first stack. It's delivering value. How do you make sure you haven't just built yourself into a corner 2 years from now? What I like to see is a focus on future-proofing from day one. The first thing I look for is a strong community. You might find that choosing tools with a big active user base is a form of insurance. When you hit a problem, someone has likely already solved it. The other big idea I always push is to build a modular system. Think of it like building with Legos instead of pouring concrete. When a better tool for one part of your process comes along, you can swap that one brick out without demolishing the whole structure. And finally, you might find it's incredibly valuable to lean on open standards. This is your best defense against getting locked into one vendor's world, keeping your options open as your business evolves. So let's bring it all together. What I've seen is that if you can just keep those 4 key layers in mind, your data foundation, your compute engine room, your software libraries, and your MLOps assembly line, you've got the complete map. The most important takeaway is to start simple. You might find that the best path to profit is choosing tools that fit your specific business problem, your budget, and the team you have right now, not the one you plan to have in 2 years. Now, we kicked off our stack with the data layer, but there's a crucial, often overlooked prerequisite. It's the unsexy but absolutely vital work that can make or break a project before it even starts. So, join us next week for episode 9, where we'll dive into Data Janitors Wanted, the unsexy but critical work of data preparation.